So now we can see I have launched my Deep Network Designer app. When you zoom in, you should be able to see the different layers that the SqueezeNet model has. If you look at the first layer and observe the properties, you'll find out that in the section input size, the dimensions are 2272, 2273 that we have previously discussed. If you scroll down and we look at the last learnable layers over here, we will find out that two layers are important for us. One is this dropout layer, another one is convolutional 2D layer. So we'll try to change the probability of this particular layer to 0.6. What is the significance of changing this value is that it affects on the accuracy of the model. You can try it with different values and then let me know in the comment section. Second one is this convolutional 2D layer. What you're going to do is we are going to drop another convolutional 2D layer over here. Let's delete the earlier one and replace it with the new one. So this is the new layer. What we are supposed to do is we are supposed to change the filter size by 3 because there are 3 classes over here. If you look at the padding, okay, over here it is same 0001111. I'll keep it to 0000. Okay. The weight learnable factor, I'll try to scale it to the value of 10. Similar is the case for this bias learn rate factor. Let's auto arrange it. Rest layers will be untouched. Let's click on analyze. This will help us in analyzing the network if everything is correct logically. And when we find out that everything is correct, we will try to export the network. So what we have seen over here is that we have been able to modify the SqueezeNet network as per our requirement. So over here we can find out the layer diagram. It says 0 errors. So we'll go to export and we'll click on the first option, which is export network to workspace. So in our model, we could see that when we export, it will by default assume the name net_1. You can keep this to be whatever you want. Let's keep it net_1. Click on OK. Now it's time when we can go ahead and train a model. So you can see previously I tried to train the model. Let me try to explain you. This is the learning rate, mini batch size, maximum echo, validation frequency over here. The solver we have taken is SGDM. Okay. Verbose is 1 so that we can get this output table over here. Plots. So right now I want training progress plot. You can get different plots over here that we'll try to see in some other series. And over here the matrix is accuracy. So with this function train net and augmented training data set, the exported network is net_1. We have cross entropy layer over here. The classes name are derived from the labels. So here the label are ARR, CHF and NSR. Okay. And then we will try to capture all the values, evaluate the score, try to display the accuracy. Then we'll go ahead and look at the confusion matrix. So let's try to execute this particular section. So one must understand that it takes certain amount of time for the model to train And once the training progress starts, you should be able to see a figure that pops up and which shows you in real time what is the training, whether the training progress, or we could say, when we try to see, we see that during each epoch, we want the model to see that it learns few new features and the accuracy increases slowly. So let's wait for some time. You could see now. So the training has started. You could observe over here epoch 0, epoch 1. You could observe this training loss value, accuracy value, and so on. Now you can see this is the training progress that I was discussing about. And one more thing you might have noticed over here is that the hardware resource. So here, the hardware resource that I'm talking about is single GPU. Why? Because my system by default has a GPU, so MATLAB has a parallel computing toolbox. This parallel computing toolbox tries to look at the best resource that you have. So now what has happened is that for this training, what hardware is utilized? So this single GPU resource is utilized. We can observe now that the accuracy is slowly increasing with the epoch. Okay, as well as if we look at the loss curve, similarly we find out that the losses are also decreasing. You could see the status is running over here, and it also shows you the elapsed time along with which epoch it is particularly running, okay, the learning rate, and so on. So let's wait for few seconds. We have almost reached up to epoch 11. Epoch 12, 13, 14, and now it's 15. So you could see that the training part is completed now. Let's minimize this figure. So this was the verbose that I was talking about. And the accuracy is 90% over here, which is very good for us. So I would say that anything which is close to 90 is a very good result. The result which is very close to 100%, there are some problem associated with that. Probably you could say it's related to overfitting. Let's go to the last part. Okay, so there are two ways that how we can represent our results. So it could be represented in terms of confusion matrix. So we have this validation data set. So whatever labels are there, okay, and we have y predict over here. Whatever labels are there that are predicted over here. And another way to do this is in this way, right? So we could see that there were 19 samples for ARR. One has been misclassified and represented as CHF. CHF, there were 6 samples, so 2 has been misclassified over here as ARR, whereas when we talk about normal sinus rhythm, or 7 has been correctly classified. Now it's your task that you can use this confusion matrix and evaluate F1 score, recall, precision, and other things. That's all in this series. Thanks a lot. If you like my work, please do subscribe my channel. Thank you.